Hi there. In this video we're going to take a look at AQA's Mathematics Unit 1 exam for the higher tier from March 2011. Okay, question 1. Is money discrete or continuous? And in fact we can actually tick both boxes. Discrete or continuous will get you the mark so long as you can give a valid reason. One of the reasons for discrete is you can't have less than a penny. That will get you a mark. Or if you chose continuous, you could quote exchange rates. Question 2. A company pays people to visit shops and test customer service. Paul works for this company and it gives his fees for October. We're asked to calculate his mean fee. So this is a discrete frequency table. So what we're going to do is we're going to do the fee times by the frequency for each one. So working that out, we get 8 times 10 is 80, 10 times 18 is 180, and so on. So we do that for each fee. And then what we do is we work out the total of all of these here. So 80 plus 180 plus 84 plus 60 plus 20 gives us a total of 424. And we're going to divide that by the total frequency, which in this case is 40. So with our calculator, we're going to do 424 divided by 40. And plugging that into a calculator, we get 10.6. So his mean fee is £10.60. Next question. It says Paul says that his modal fee and his median fee are both £10. Is he correct? Well, the modal fee is certainly £10 because it has the highest frequency. The median fee will be found at the 20th value, which if you add these up, 10 plus 18 gives us 28. That means the mean fee is also 10, so we can say yes, he is correct. So it is true, the mode is £10, highest frequency, and the median is found at the 20th value, which is also £10. 2C. Shelley also works for the company and her fees are shown in this line chart, and we're asked to show one similarity and one difference. Now there's lots of different answers you could have given. I said that a similarity was that they both had a mode of 10. As you can see, the highest frequency here is £10. And a difference I suggested was that Shelley's lowest fee had a frequency of 2, whereas Paul's lowest fee had a frequency of 8. So her lowest fee had a frequency of 2, we can see that there. And if we return to the table, Paul's lowest fee, £8, had a frequency of 10. I should change that to 10. Okay, moving swiftly on. We're told that 147 trains leave Leah Road Station, and one day most trains are on time. It says 19 trains are late, and we're asked what percentage of the trains are late. So to work out what percentage, I'm going to do the number of trains that were late divided by the total number of trains. So 19 divided by 147, doing that on a calculator, 19 divided by 147 is 0.1292, giving my answer to one decimal place. That's going to be 12.9%. So 12.9% gets us our full 3 marks there. Question 3. The station manager records the number of minutes late for each of the 19 trains, and we're asked to draw an ordered stem and leaf diagram to show the data for late trains. So we'll get 1 mark for completing the key. I'm going to choose 1 to represent 21 minutes late. And what we're going to do is we're going to build up the stem and leaf diagram in order from top to bottom. So the lowest value I can see is 1, so I'm going to put a 0 here, a 1 here. Then we've got 2 next, so a 2 will go here. And continuing on, building up your stem and leaf diagram. If you're not sure, look at the video I've done on how to draw a stem and leaf diagram, and you'll end up with something like this. So that's my stem and leaf diagram completed for 4 marks. Next question. It says for the 19 late trains, write down the modal number of minutes late. So let's return to our um, stem and leaf diagram and see if we can spot anything that comes up the most. Looking at the leaves, I can see that this seems to repeat itself. So that means that 8 minutes is the modal number of minutes late. It says write down the modal number of minutes late for all 147 trains. Well, if we think about it, we only had 19 trains that were late. That means all the rest, in this case, 128 trains were 0 minutes late. Therefore, the mode for all 147 trains is actually going to be 0 minutes. Now it tells us, it says the station manager says that the late times are all 1 minute less than I recorded. So for example, a train that he recorded as 6 minutes late was actually only 5 minutes late. It says which modal number of minutes will change. Will it be the 19 late trains, all 147 trains, both or neither? Well, if we think about all 147 trains, 100 what was it, 128 of them were actually on time. So even if he's recording it this way, that's certainly not the correct answer. So that rules out both of these. If you think about it though, it must be all 19 late trains. And the reason I've given is that the mode for late trains is actually now 7, because they were actually recorded 1 minute. They were recorded 1 minute more than they actually were. So if it was 8 minutes before, it's actually now 7. In other words, if I was to go back to my stem and leaf diagram, all of these numbers would be reduced, or would go down by 1, or all of these numbers would go down by 1. Okay, moving on. It says a shop sells red roses and white roses in a ratio 7:2. One day, 392 red roses are sold. How many white roses were sold? So it's your typical reverse ratio question. So it's red roses to white roses. 392 is the red roses. So what we can say is 7 parts must be equal to 392. That means 1 part is going to be equal to 392 divided by 7. And when we do that on a calculator, 392 divided by 7 is 56. 56. That means the 2 parts, which represents the white roses, is going to be 56 times 2, which is 112. A different shop sells red roses and white roses in a ratio 8:13. What is the probability that a rose sold at random is red? So if I was to add up all the parts, we would have 11 parts in total. If I was to select one at random, there's an 8 in 11 chance that I select a red rose, because they're in the ratio 8:3. Moving on. A company makes 200 Easter bunnies. It costs £2.46 to make each bunny. 28% are given to charity. 3/4 of the rest are sold for full price, and any left over are then sold at half price. How much profit? So again, it's similar to the last paper. I'm just reminding you, profit is equal to the sales minus the costs. So let's start by working out the cost. The cost in this case is going to be 200, because we're making 200 bunnies, multiplied by 2.46. So doing that on a calculator, 2.46 by 200 gives us £492. So they're spending £492 making the bunnies. 28% are given to charity. So if we think about it, if they're given to charity, that means they're going off for free. So that leaves them with 72% left. 72% of the bunnies they'll sell. So 72% to sell. How many is that going to be? Let's work out 72% of 200. Well, let's just tidy that up a bit. 72% of 200 equals 200 times by 0.72, which gives us 144. So they've got 144 bunnies that they're going to sell. Now, 3/4 are going to be sold for full price. So I need to know how many 3/4 is. So I want 3/4 of 144. So 144, working out 3/4, we get 108. So 108 bunnies at the full price of £4. So multiplying that by 4, we get 432. And it says the rest, which is 144 take away 108, in other words 36, are going to be sold at half price. So that's £2 each. 36 times by 2 gives us 72. So that's £72. Okay, so we're going to add these two numbers to get the sales. So sales equals 432 plus the 72 gives us 504. And then the profit is going to be equal to 504. Take away the 492 they spent, which gives us a grand total of 8 and 4, which is £12. So they made £12 profit. I wouldn't want to work for that company. Okie doke. Next question. Matt and Ruba each have one coin, and it tells us the total amount of money is less than 50p. Work out the probability that exactly one of the coins is a 10p piece. And it also tells us that we should assume that all coins are equally likely. Now what I've done here is I've actually just drawn a two-way table. If we think about it, if the total amount of money is less than 50p, then the only coins they could have are 1, 2, 5, 10 and 20p coins. So that's all the different combinations they could have. So we've got a two-way table drawn up like this. Suppose this is Matt up here. These are the coins he could have. And this is Ruba over here. Let's just tick off which combinations they could have. Well, if Ruba has 1p and he has 10p, that's fine. That's less than 50p. We could also have this one, 2p and 10p, that's fine. 5p and 10p, that works. 10p and 10p not allowed because we only want exactly one 10p, so we can't use that. 20p and 10p, that's absolutely fine. We could have 10p and 1p, that's fine. 10p and 2p here, that's fine. 10p and 5p, that's fine. 10p and 20p, that also works. So if you think about it, these are all the outcomes we could have. There's 25 different outcomes, 8 of which we're happy with. So that means the probability of this happening is 8 out of 25. Moving swiftly on, Maggie interviews a random sample of local people, and she asks, what percentage of the MPs do you think are female? So write a suitable response section for this question. Now, I suggest you look at the video I've done on questionnaires, because this is a typical question, and all we're going to do is we want to make sure we have some tick boxes and that there's no overlap. So here we have it. Here we've got a tick box section that people can come along and choose a correct answer. So let's just say tick one box. and people will come along and tick the box that they think is appropriate. Just notice as well that I don't have any overlaps here. That goes up to 20%, and then the next box goes from 21 to 40. Again, no overlaps, very important. Next question, give an advantage of interviewing people instead of using postal questionnaires. Lots of different things we could have said here. Cheaper, faster, more reliable. So that's what I've said. It's cheaper, quicker, or you're more likely to get a response. People could ignore the postal questionnaire. This question here, it says, at the beginning of 2010, there were 126 female MPs. That was 19.5% of the total. Calculate the number of male MPs. Okay, so what percentage would male MPs be? So it would be 100% take away 19, take away 19.5%. Subtracting that, we get 80.5%. So 80.5% will be male. 1 mark if you can do that. Okay, so I know that 19.5% equals 126 people. So if I work out 1%, I'll do 126 divided by 19.5. So 126 divided by 19.5 is, I'm getting 6.46. So we'll actually have to round that to, or we can leave it as it is for now, 6.46. Let's see what happens. If I multiply that by, so we do 80.5% is going to be equal to, so I'm going to multiply the answer I have in my calculator now, multiply that by 80.5, and I get 520.15. So I'm just going to round that to the nearest person, which will be 520. Okay, so moving on now, we've got 520 males. Let me just write that down here. 520 males and 126 females. 126 females. Okay, Maggie questions a sample of MPs stratified by gender, and it says to complete the table to show the number of MPs in the sample of 50. If we remember from the last question, we had 19.5% female, and we had 80.5% male. Well, that just means the proportions of 50 must be the same. So I'm going to need 19.5% of 50 to get the number of females. So if I do 50 multiplied by 0.195, so for the number of females is going to be 50 multiplied by the proportion I have, 19.5%, or in this case 0.195. Converting the percentage to a decimal, we get 9 3/4, which I will have to round to 10 people. That means that 40 people must be male, but let's just confirm that by checking it out. So if I do 50 multiplied by the proportion of males, which is 80.5%, or 0.805, so doing 50 times by 0.805, we get 40 1/4, which we have to round to 40. Okay, the next question. Two groups of people are trying to lose weight. So we got group A who are in the gym, and here's a cumulative frequency diagram representing that. How many people are in group A? If you look at the very top here, what is my cumulative frequency? At the top of the graph, it's 60. So the number of people in group A must be 60. That's the total number of people. Does everyone in group A lose weight? Well, if you look down here, the graph actually starts at 0.9. That means that everyone did lose weight, because the diagram doesn't start from 0. If it started from over here, we couldn't say for sure. In fact, I would say no. Next question. It says we got group B here shown by a stem and leaf, or a box and whisker plot, And we're asked, does everyone in group B lose weight? Well, if we look at the minimum value, which comes from here, the minimum value is actually less than 0, so I would say no. Some people have actually put on weight because the lowest value is less than 0. And we're asked to compare the weight loss of group A with group B. Now, if you've watched the video I've done on comparing distributions, you should think, well, I want to comment on an average, or more often than not the medians, and also a range or interquartile range. So range or the interquartile range, and then we want to draw some conclusions. So let's take a look at the median of group A. So if I come along, we had 60 people, that means the median must be at the 30th person. So drawing a line across and down, I can see that the median for group A is 1.2. So the median of A is 1.2. Well, what about the median for B? The median comes from this line here, which is 2.5. So I'm going to state these facts. What about the interquartile range for group A? Right, the median or the interquartile range is going to be calculated by getting the upper quartile, which I make out to be 2.6, and the lower quartile, which I make out to be 0.9. So subtracting those, we get 1.8. So 2.7 take away 0.9. Maybe I think when I did this originally, we move it over a little bit. Again, you do get a bit of tolerance in the exam, so don't be too worried about that. Be as accurate as you possibly can. That's the interquartile range for A. The interquartile range from B is going to come from here, which is 3.1 take away 3.1 take away 1.5, which in this case gives us 1.6. Now, what conclusions can I make? Well, on average, group B lost more weight than group A. So I'm going to state that because their median is higher. And what about the interquartile range? What does that tell me? Well, group B has an interquartile range of 1.6. That means the data is closer together, so that means they were more consistent. Or, in other words, you could say that group A was actually more varied. Okay, moving on. Question 9. We're giving a table of information about the length of time that 180 people are shopping. So here's our table. We're asked to draw a suitable frequency diagram. Now I'm looking at this and I'm seeing class intervals that are different. So immediately I'm thinking about a histogram. Usually when we see class intervals that are not the same, or class widths that are not the same, we should be thinking of a histogram. You can do a cumulative frequency diagram, but I'm just going to do a histogram here. So the first thing I got to work out is I need to work out the class width for each one and the frequency density. So if you remember, the frequency density is the frequency, I'm going to call it F here, divided by class width. So I take the frequency and I divide it by the class width. The class widths for each one. This one is 90 because 150 take away 60 is 90. 180 take away 150 is 30, and so on. So that's the class widths for each one. Again, if you're not sure, do look at the video on histograms. And then I work out the frequency density for each one. So there's all our frequency densities. Now the next thing I need to do is actually put in a scale here. So I've chosen a scale of 0.2, 0.4, 0.6. So each 10 lines up the grid, kind of difficult to see. I've chosen a 0.2. Now, yours may be slightly different. And now I'm going to start to draw in my histogram. So, I need a box that goes from 60 to 150. So, there's 60 up as far as 150. And it should go up to 0.2 in this case. Then I'm going to draw in a box from 150 to 180, 150 up to 180 with 0.45, and then continuing on, drawing your histogram, you'll end up with something like that. So that's the histogram completed. So that's my 3 marks. I'm asked to calculate an estimate for the average length of time for those people who are shopping over 3 hours. Now this was a tricky question, so let's go back to our diagram. Um, if I think about it, I'm only interested in people who are shopping more than 3 hours. There's 60 minutes in an hour, so I'm only interested in everybody greater than 180. In fact, I can get rid of these 2 bars. I'm not interested in those 2 bars anymore. I want to know what's the median time for these 2 bars. So the frequency of this bar is 60. The frequency of this bar here is 36. And again, if you've seen my video on interpreting histograms, this should be okay. The total number of people in these 2 bars is 96. That means the median is going to be the person halfway along. So we'll do 96 divided by 2 to get 48. So I'm only interested in 48 people. So the 48th person. Now, once again, just remembering this bar here is worth 60 people. I only want 48 of it, so I need 48 out of the 60, that proportion of the class width. The class width in this case goes from 180 to 240, or in other words, the class width was actually 60 in total. 48 over 60 multiplied by 60 is 48. So I'm going to add 48 onto my 180. 180 plus 48 gives me 228 minutes. So that was the average length of time for people shopping over 3 hours. 228 minutes. Okay, moving on. Last question here. 2 people are chosen at random from the 180 people. Estimate the probability that both are shopping for less than 2 hours. So I need to go back to my diagram. Let's just bring it back into play here. So both people are shopping less than 2 hours. 2 hours is going to be 120 minutes. So how much of this class width do I actually need? I only needed to go from 60 up as far as 120 minutes. It goes from 60 up to 150. So I only want a class width of 60 here and not 90. Class width is going to be 60, and the frequency density we know is 0.2. So I want to know how many people are actually in here by working out the area of the bar. So doing 60 multiplied by 0.2, we get 12. That means there's 12 people in this region here. So suppose I choose somebody at random from the 180 people. Well, the probability that the first person is in that category, there's 12 people in that category out of the 180 people. And then I'm going to choose again because we're choosing 2 people. What's the probability that the next person is in there? Well, 1 person has been taken out, so that means there's 11 left. But now there's only 179 people left. So doing that on a calculator, we do 12 over 180 multiplied by 11 over 179, and working that out, we get 11 over 2685. 2685. That's it for this video. Bear in mind, some of the questions I've answered here have different solutions in the mark scheme depending on which way you tackle the problem. I can say though, everything I've done here is in the mark scheme as worth full marks. Hopefully you enjoyed the video. Hopefully you found it useful. Best of luck with the revision, and I'll talk to you again sometime.